Hello, this is a video on generating tracks for NGS, day 1. First, we'll be using Globus to transfer our base space information to Quest. So you will use the RDSS, Northwestern Quest, and then you'll go to your username. Then you will click through until you get to the NovaSeq folder. There's a lot of files, so it kind of glitches sometimes, so I apologize. Then once in there, you'll find the file that was created on the NovaSeq or the NextSeq, depending on which service system you're using. Then you'll transfer it to Quest, so Northwestern Quest. And you'll go to the directory that you want, so we usually transfer our files into the NextSeq directory. Go to Projects B1025. Then to the NextSeq folder, and then you'll press Start. Then once you press Start, it will show up as an activity on Globus, and this transfer takes about 30 minutes depending on when you submit it, and so I did this about an hour ago. While that is transferring, we'll be creating a project folder within the Tango folder within B1025. So you'll log into Quest, then you maneuver to that folder, Tango folder. Then you will use the command, well, first we're going to look at the file, then we're going to use the command makedir, or mkdir. The directory I'm making right now is actually very long, so it has a lot of projects within it, so it's a long title. Usually there's only about 3 together at one time, but we ran a lot of samples together. Then you'll hit enter, and then I'm going to go directly into that folder. And I'm going to use ls just to look in the folder. There's nothing there, so now we're going to transfer over the sample sheet using CyberDuck. So you'll use the FTP and then put in quest.it.northwestern.edu. And then you'll use your username and password and then connect. And then you'll navigate directly to the folder that we're in right now. I use CyberDuck because it's a very good visualization tool, so you can actually see all the folders and everything that you're doing within those folders. So then you go to Tango, and that's the long folder name, and there's nothing in it right now because I haven't put anything in it yet. So now I'm going to go to our lab folder. So make sure you connect your VPN, go connect to server, connect, and then load for a little bit. And navigate to that folder that our sample sheets are in, because we're going to transfer the sample sheet that was created with all the files, with the index names, and all that different information, so that we can do the BCL to FASTQ and then the alignment and all those scripts and things like that. So there's a lot of sample sheets, so sometimes it loads for a while. Then you're going to drag and drop it into the folder in CyberDuck. Very quick transfer. And then typically for this, then we're going to then rename this file to samplesheet.csv. And so first I want to actually look at it because I like to see the whole file in general, just make sure, yeah, we're doing RNA-seq. We look at different genomes, so MM9, HG19. And then usually there's some samples that or some files that only have one genome, and then you're able to just simply do the sample name and then call it samplesheet.csv. I typically also look at how many lines are created, so I use the command wc/l, and then so like I said, if you didn't have different genomes, you would be doing just samplesheet.csv, and then you'd do the things that are going to be talked about further. But we have multiple genomes in this, so we need to split this up. So we have HG19 and MM9, which is typical. So right there I have checked how many samples we have. We have 56 samples. So I use this star command, I use grep, and then S15 star, and then it shows that there's 15 samples within it. Then I'm going to also then grep for MM9. Check how many samples then are within it. And there's about 28. And then I'm going to make a new file called samplesheet.csv.mm9 just to make sure to show that I have just MM9 samples within this sample sheet. Then I created those files, and then I'm going to do the same thing with my HG19 files. So there they are. I also want to see how many samples there are just to make sure. So I do wc/l, and that's 28. And then I'm going to make a new file called samplesheet.csv.hg19.csv. Okay, and then we're going to have to take the header information, because right there, when we use the grep command, it only took the lines that had HG19 or MM9. So we need to make sure we have the header information, or else BCL to FASTQ won't run, or the pipeline generation will not create. So we're going to use the command nano, and we'll do sample sheet. I use the to get those things to fill out fast. I just use the tab to tab over, and it generates the names faster. So I paste that, and then I will exit using the Control X, and then I want to save, so I say yes, and I say yes, I want to save it as that name. And then I'll do the same thing for HG19, so repeat, and then I will do the same thing. I'll do Control X, and then Y for yes, and then enter. And then from there, I'm going to just look at the sample sheet again just to make sure. And we're good. That's what the header information looks like. So yeah, now we'll proceed on to building the pipeline. And so what we need to do first is to copy the sample sheet that we have. So we're going to do MM9 first, and we're going to copy that and call that actually samplesheet.csv, because BCL to FASTQ needs it to be called that specific name, and so does the pipeline as well. So as you see, the file size is the exact same, so it's the exact same file. So if you see here on CyberDuck, it also shows that too. And so now I'm going to copy that samplesheet.csv over into the base directory that we transferred on Globus once the thing on Globus has been transferred. Of course, you won't be able to do this unless the file has been transferred, so you got to make sure, go back on Globus and make sure it's there. So now I'm going to go into CyberDuck and actually go make sure that directory is there, make sure that file is correct. Oh, and it is. It has the same size, or similar size, and then we will build pipeline. So first I'm just going to show you what each of the flags for this thing is. So it's projects, B1025 tools, and then build pipeline. And I tab over and it shows the whole word. Okay, and then here are all the flags that you can use for this pipeline. So we will use specifically -O, or the output directory, -B, the base directory, -P, so the processors, I usually put 15, -G, which is the genome, -T, which is like either ChIP-seq or RNA-seq, and in our case RNA-seq. So we're just doing RNA, and then our count number, so B1025, and then we're going to build BCL to FASTQ script and a build alignment script. So we'll call those with both ones. And so you use the top arrow up, and then you don't have to fill it out. And then so you do -O in the output directory, so the one that I'm in right now, -base, and so where I just copied the file, so I'm just going to copy that. And then we're going to use -P, which is 15, -T RNA, -G, oh, account, sorry, B1025, -G, and that's then MM9. So you can do this in any order. The flags can be put in different things. Oh, and we also use this flag -Q buy-in. That's specific. It's not in the flags, but you need to put that there. And then build BCL to FASTQ 1, and then build align 1. And then you'll hit enter, and then it's going to create all these different folders and files that you're going to need to use. So it creates all those scripts and things like that. So as you see, there's 2 tangos within MM9, so HG19 will have the other 3 files, well, projects. So what I'm going to do is now run BCL to FASTQ. Now, BCL to FASTQ has different calls for NextSeq and NovaSeq, so you have to actually nano and change the NextSeq because the build pipeline is actually made for the NextSeq. So you have to change BCL to FASTQ's version to 2.19.1, and then you also have to remove the flag -D15 because the NovaSeq doesn't need that for BCL to FASTQ. So then you'll hit $X and then yes and then enter. And then you're going to submit it as a job, and you do SBatch, run BCL to FASTQ. And then you can watch the thing, so watch SQ, and then your username. And then you can watch that as it goes. And then I also like to see it within CyberDuck to actually see how the files are generating. So it takes a little second to load. Sometimes you have to go back and go back again. Load. Yep, so there you go. So it shows you the undetermined files, and then it also shows you the two projects and all the samples within that project. So as you see, it's being generated, so we know that the reverse complement doesn't need to be done in this case because it runs just fine. So then once it's all done running, you check the actual file size, and it looks good. It's about 600 MB. And that one's about 400, 500, so that's pretty good. You just check some files, and usually they all have been generating as equally. So then you're going to want to go to the project that you are in. So I'm doing 1486, and then I'm going to go to the FASTQ directory. And I'm going to move my FASTQ files now over, that I just generated, over to this directory. So I'd use project B1025, NextSeq, then the base folder name, then data intensities, base calls as you see here on the top of CyberDuck where we're located. Base, then the Tango number, which we're in 86. Then we will go in and we'll do S* because all of the files there have an S to start, and then they all end with a fastq.gz, and I want it at this location, so I put a dot because that's where I want it to go, where I want to move all the files. Now I just check to make sure they're all there and that the file sizes are good, and they all look pretty good. There's a lot of them there, but yeah, all about spanning from 450 to 750 MB. Okay. Now we're going to move back, and we're going to do the same thing with the other directory, with the other project, sorry. So for 1493, we're going to do the same thing. Go into the FASTQ and make sure there's nothing there. There isn't, so cool. And we're going to do the MV command, or the move command, once again. Not Tango, NextSeq. And then the base file, then data intensities, base calls, then Tango 1493, S*, and then star.fastq.gz. And then I want it at this location, so I space it and I put a dot. Then I make sure they're there, and the file says they're good. Cool. So now that I did that, you would have to do the same thing with HG19. We'll have to build the pipeline again. You have to make sure you call it samplesheet.csv, and then you move that sample sheet over to the base space directory again. It's a little bit time consuming, but it's the best way to do it rather than generating it for the whole thing and then having to go back into the individual scripts and change the genome. So again, you're going to move it over to the base space directory. Then once you've done that, press enter, and then you're going to then do the same thing, but instead of for the flag-G, you're going to do HG19 instead of MM9 like we did before. Then you'll hit enter and it will generate more of the folders and more of the files that need to be created. And as you see, when we do LSLTR, there is all the 3 other projects. Now that those are generated, we're going to want to actually go into our RNA scripts because RNA, the top hat aligner that is used here, doesn't like extra lane information. So we only have, for our S1 run that we just did, we only have 2 lanes, so lane 1 and lane 2. So we're going to eliminate lane 3 and lane 4. So I'm using TextMate. I drag and drop from CyberDuck directly to my desktop. And I clean it up a little bit, and then I go into and make a folder on my desktop so that I know which project I'm doing, and I'm doing project 1492 in this case. Yeah, I gotta make sure though. Yeah. So then from there I'm going to open it up, and then I'm just going to look over the whole script in general. This is everything that will be running. It takes about an hour and a half to run. As you see, the first part is the trimming of the FASTQ files, and we see lane 1, L002, lane 2, and then L003, lane 3, and L004, lane 4. But we don't have information for 3 or 4. We don't have any FASTQs generated, so we just delete those trimmed information there. And then we're going to go over, all the way over, till, because this is the line here, is the top hat information. And this is the call for all the information that top hat needs to run. And it doesn't like not having files present, so it will just stop and get angry. So you got to remove lane 3 and lane 4. So we have lane 1 and lane 2, so just go over, and it's kind of tedious, but scroll on over till you get to the little caret, and then you just delete. And so now we only need, we only have lane 1 and lane 2, which is good because those are the FASTQs that were generated. I'll save it, and then I'll move it back into CyberDuck, and I'm actually going to override the actual file that was already in there. Okay, so it's transfer. I'm going to overwrite. Let's continue, and then I'm going to put that file into my folder so I know I already did it. So now that I've done all the scripts for every single project, I'm going to use this fun command, the find command, which will be for submitting all the jobs. And so instead of just submitting each of the jobs separately, doing sbatch this .sh and then keep going through, you're going to do all of them in one simple line of code. Got to make sure when you copy it though that you have the right characters in there, because if not it won't work. So just change that little apostrophe, then you press enter and it runs. Then I'm going to watch it. So watch SQ-U BC7539. Okay. And so then you're going to watch it, and to get out of this you would use the Control C to get out. And then I'm going to watch that a little bit, and this takes about an hour and a half for each one. So now we're going to run into day 2. So after everything has been run, we want to make sure that all the files are there. So we're going to go into the project that I know has been created, so 1492. So I'm going to go into each of the BAM folder. So you see how they have all those different folders. So as you see, there's some BAMs generated, bigwigs generated, counts, logs, all this different stuff. So I'm going to then also go into the top hat. You can see that each of those files will have other information within them. You can just play around and look at it and get familiar with it. So then I'm going to go to another file, project 1493, and this one I know is done as well. So I'm going to check out the FastQC information, or the quality of the FastQs, and I'm going to use the files that are screen.html. And this will give us information on like the ribosomal content, if it was aligned with different genomes, because there could be potential contaminants. And so I'm going to copy these files directly to my desktop. So I'm going to use the secure copy, or SCP, and then I put my username at quest.northwestern, and then the project I'm at, and then the file. Then I put in my password, and then I hit enter, and then it will download, and then I go right to my desktop. And I will click and open the file. So for this one, you can see that it has a ribosomal content of 21%, so that's okay. And then, but then there's this other thing down here that could be a potential contaminant that we discussed later when we sent out the email. Typically that doesn't even show up, and typically the ribosomal content is sometimes lower than that, but it's okay that it's below 30%. So now we're going to actually go on AWS, because everything was uploaded to AWS, and we're going to make those files public so that UCSC browser can actually look at those files. So we go into, in this case, KCAs, into the Tango number that we were using, or the project number. And in this case it was 86. And then I'm just going to look at the files. There should be around like 30 and above. I've seen some that get to like 60 MB, but yeah, typically it's around 35 and above. And so I'm going to click them all and then go down and make public. And so then, since it's public now, I'm going to go into my directory that I was just in for the Tango 1486, sorry. And then I'm going to be copying and pasting the header information for our bigwig files, which are the bigwig files were then uploaded to AWS, and so this will give us information on actually what we're going to copy and paste into UCSC browser. So I'm going to do the cat command, or the concatenate. So cat star.header.txt. I'm going to enter, and that's going to be all the header information that's within the tracks folder. So yeah, I have to make sure you're in the tracks folder and do that command. Then you're going to copy this whole thing. This has for each sample. So copy that. I usually put it in my notes, and just to keep me organized, I make sure I put the Tango number, and then just make sure I say it. So it's the header for a UCSC browser. And this information I also put at the end of each of the emails that I send out to the researchers. So I want to go specifically into one of the tracks, header tracks, just to show you what they individually look like. They're about 3 lines. You see the type of track. It's a bigwig, the name of the track, and like the description of it, and then it will actually have the URL and other command things that make the UCSC browser look good. And so that's where the URL where the bigwig file is actually located. And so if you don't make that public, it wouldn't be able to actually go into that URL and take that information from the bigwig. So now we're going to go into the top hat folder. And we're going to use, similar to what we did for submitting a job, we're going to use the find command to get the alignment information. So we'll use that and make sure when you're copying and pasting it's good. But for RNA-seq, it's different how the alignment information is shown. So it's in a TXT format, so a text file format, whereas in ChIP-seq, it's in a log format. So you'll have to change that star.log instead of for ChIP-seq, but for RNA-seq, it needs to be star.txt. So as you see it in the protocol I created, that's where it has all that information. So I'm going to copy and paste all this information into my notes again. And this is the information that I will send out in the email as well. And I also like to check, and I'll check in a little bit, just to make sure the inputs were good and the amount of processed reads were correct. So from there, I'm going to create a UCSC browser session. So to do that, you see here we go to UCSC browser. And we're going to make a username, password, my username. I just use my NetID. And then I'm going to do genomes, and I'm doing MM9. There we go. And I had already created some files from before, and so I need to, those were actually saved in a different session, so I can manage those and delete them because they're already saved in another session. So I click them all, delete, and then I add custom tracks, and this is where I'm going to copy all that header information that I got off of Quest. So I highlight all that, and many years later, after going all the way down, there's a lot of files, samples. So then I copy that, and then I paste it directly into that, and then I press submit. From there, you press go, and then the session is created. We're not in the exact region here, so there could be other places where the researcher knows where to go, and it will have reads there for them. So then you will want to save this, so you'll say My Sessions, and you look down, and where it says MM9, you're going to actually change that to the person's initials, and then the Tango number. So 86, and then submit. And so now you have that there. Go to it, and I'm going to do an email. I don't actually use email on here. I go directly on the browser, so I just copy that. And then I put it in my notes. And I like to make sure that it actually worked when the hyperlink does it. So, oh, it does. Okay, good. So from there, I'm checking the alignment information. So it looks good. There's nothing lower than, like, there's 68%, but that's okay. Anything lower than like 65, 60% is a little concerning, so you have to make sure you look at that and maybe talk to some people about it and what might have gone wrong. So I'm going to show you an example of one of the emails I sent. And pretty easy. Just say hello, say a little description of it, copy the information for the browser information and the alignment, and then below that I'll have the tracked information in case they want to generate. And thank you.